So today we have an interesting question from Sir Michael Penn's recent video. His recent video was on this same geometrical question, and his title was that is there any other method to have the area? So here's the other method. So first thing, that's the given data is that there are two right angle triangles, the 90 degrees present over there. They are intersecting with each other. You can just have a clear look in this diagram. The lengths are given of 2, 6, 8 and 4. You can just have a look. And what we have to do is find the area of this shaded region that has been marked over here. That's the white lines over there. So you have to find this shaded area. Sir Michael Penn used the coordinate system, and I am going to use some kind of trigonometry to solve it. So let us see that. So first of all, I am just removing this shaded things from here, so we can just mark some things over there. So let the shaded, remember that what was shaded, let that be equals to x. The remaining, let it be clear, yes, first of all. So this is x, this remaining let it be equals to b, and let this be equals to a. So I can have that area of the complete, here's the 90 degree. So area of the complete, let it be equals to s. So area of complete triangle, that's triangle ACD. Its area would be half base into height, so half of 8 into height of 8. So that is equals to 32, and it will be equals to x plus a. So x plus a, because there are two areas present in that same thing. So we have that x plus a is equals to 32. Similarly, if we have the area of the triangle, that's triangle BCE. So its area would be half the base, that is 8 plus 4, 12, and height that is equals to 6. So that will be equals to somewhat 36. So 36, and that will be equals to x plus b. So x plus b is the area, means x plus b is equals to 36 and x plus a is equals to 32. Now if I want to means if we have two equations like x plus y is equals to 9 and x minus y is equals to 1. If you have two equations like this one, means there are two variables present. So we can just clearly cancel them out and we can solve for 1. But here there are variables, means equation present are 2, x plus a, means these two equations. But variables are 3, that is x, a and b. There are 3 variables. So we have to either exclude one. So x cannot be excluded very easily. But I am just thinking to just have the relation between a and b, like a is equals to k times b, means a comes in terms of b. Like a is equals to the area of b, but not exactly b, but some kind of, it can be b when k is equals to 1. So I'm just thinking to bring them to relate to each other. So a is equals to k times b. So to bring that, if a upon b is equals to k, so to bring means like that way I have to either bring the area of a and b in this form or else either in that form. So first of all, how their area will be calculated, like area of a right angle triangle can be calculated very easily, that's half the base into height. How can we calculate that? So area of that was a, area of that was b, that is b is this, a is that, remember. So these two angles are vertically opposite angles, so let it be equals to theta and theta. So remember the formula that there is a triangle, the theta means this angle is theta, the adjacent sides are p and q. Then area of this particular, let it be clear first of all, yes, if that is q, then area of this particular triangle is half sine of the angle, that is sine of theta, and into adjacent sides, that is p and q. This is the area. We have the area half of base into height if I draw the height over there. So similarly, this is also a formula if the angle is given and the adjacent sides are given. So we will use this formula to have the area of a and b. So first of all, I have to, as I told you, I have to bring a upon b, means I have to calculate their area and bring them in ratio so as to have one in the form of other. So first of all, area of a would be half of sine of middle angle, that is sine of theta, into its adjacent sides. So let the mark adjacent sides, let it be equals to, starting from here, let it be equals to a, and removing this b and a from here first of all, yes. So a, let that be equals to b, let this be equals to c, let that be equals to d. So we have that area of a, that is upper triangle, is half of sine theta and adjacent sides, that is d into c, and area of b would be half of sine of its theta, that's sine of theta, and adjacent sides, that is a into b. So a into b, the b was this and a was on the top, and using this formula this two came. So from this thing, the good thing was that half and half, sine theta and sine theta got cancelled out. So we got that a upon b is equals to c into d upon a into b. This was nice, but c and d, a and b means they were not getting cancelled out. We are obtaining a and b in again some kind of variable. So now how can we cancel them out? So to cancel them out, we need c and d in terms of a and b. If c comes some things like m into a, and d comes something like n, means m and n are some kind of integer. So m into a and d comes something like n into b. So when we replace them over there, so a and b gets cancelled out, and m and n are perfect integer. So we can obtain the value of that thing in some kind of perfect integer. So let us bring d and b in terms of that. So now what we will do is apply the sine rule. So applying the sine rule in that bottom triangle that has the area b, that's this one. And let us mark the angles also. Let this angle be equals to alpha. Yes, let this angle be equals to alpha. Let this angle be equals to something like beta. And if that is beta, this inner one is going to be 180 minus beta. So yes, so sine of alpha, so sine rule means sine of angle upon its opposite side. So sine of alpha in that triangle. So the triangle is ODE. Yes, in that triangle, sine of alpha upon its opposite side, that is A. And that is equals to sine of theta upon its opposite side, that is 4. That is equals to sine of beta upon its opposite side, that is equals to B. Now the thing over here is that we can have a very nice value for sine alpha and sine beta. Look carefully in the triangle BCE. Yes, in triangle BCE, the BC is 6, CE is 12, and here's the angle alpha. So and the hypotenuse becomes 6 square root of 5. So we can have the value of sine alpha in this, that is 6, that is b equals to 6 upon 6 square root of 5 is the value of sine alpha. So we get that sine alpha is equals to 1 upon square root of 5. Similarly, in that same triangle, let this be angle something like, let this angle, the variables are going less. Yes, so just remember. So the angle, let it be some kind of variable p. Yes, p we have not utilized, p over there. So it's going to be 180 minus p, and let that be equals to q. So in the same right angle triangle, that top angle is equals to p, and we are going to utilize that further. So writing that also, sine of p is 12 upon 6 square root of 5. So it forms 2 upon square root of 5. Now how can we calculate the value of sine of beta? So for that we need that upper triangle, that's 2 of its angle are, means not the angle, the sides are 8 and 8. This, according to the diagram I have just marked, this is equals to angle q, and this is angle equals to 180 minus beta, as I have marked that as beta. So this angle is going to be 180 minus beta. So 180 minus beta, no problem, 180 minus beta. Now as these two sides are equal, these two angles are going to be 45 and 45. So sine of q gives me sine of 45, and that's nothing but that's 1 upon square root of 2. And sine of 180 minus beta, I am just writing it that only, sine of 180 minus beta. I know that sine of 180 minus beta is 45, but I am writing it as 180 minus beta only, and that is equals to sine of 45, and sine of 45 is 1 upon square root of 2. Now remember the identity there, sine of 180 minus theta is sine of that same angle. So sine of 180 minus beta becomes sine of beta. So here we have the value of sine beta. So writing all of them together, so sine of beta we have the value, here we have the value of sine of q, here we have the value of sine of alpha, here we have the sine of p. So all these things will be utilized over there. So for here we need sine alpha, sine beta, so alpha is over there, beta is over here, so putting their values. So sine alpha is a value 1 upon square root of 5 times a, that's equals to sine of theta upon 4 as it is, and that's equals to sine of beta, that's a value 1 upon square root of 2 times b. So this is the first equality we obtained. Now applying the sine rule in the top triangle that was having the area equals to a. So that triangle is triangle ABO. So triangle ABO. The sine of q, so sine of q, yes, I am just zooming it over there so everything is clear. First let me recall over there. So sine of q upon c is there, yes. So sine of q upon its opposite side, that is c, is equals to sine of 180 minus p. I am just zooming it over there afterwards, sine of p upon d. And that's sine of theta, yes, that's sine of theta, let it be clear, yes. So sine of theta upon its opposite, that is 2. So I'm just zooming it over there. Yes, you can look, sine of 180 minus p, the q, the theta, its opposite. You can just have a look quickly over there. Yes. So now we have the value of sine. Now remember, sine of 180 minus p is nothing but it's sine p. According to the identity, sine of 180 minus p is sine p. Now we have the value of sine q over here, that's 1 upon square root 2. So 1 upon square root 2 into c. Sine of p has a value where it is, here it is, sine of p is 2 upon square root of 5. So 2 upon square root of 5 into the variable that's d, and that's equals to sine theta. Yes, let it be clear, yes, d, and that is equals to sine of theta upon 2. This is the second equality we obtained. Now from here we can have the value of sine theta in two ways. If I compare sine theta with this, I get the value of sine theta, that's 2 into 2, 4 upon square root of 5 times d. And if I compare sine theta with this, I get the value of sine theta, that is 2 upon square root of 2 times c. So these are the two values of sine theta I can have from here. Now similarly, I can have the value of sine theta, means two values of sine theta from here. If I compare sine theta with this, I get that sine theta is 4 upon square root of 5 times a, and if I compare sine theta with this, I get that the value of sine theta is 4 upon square root of 2 times b, square root of 2 times b. So these are the two values of sine b theta from there. So just marking it with some other color, so it's clear. Sine beta over there, sine means not beta, sine of theta we have two values there, and sine theta two values we have here. Now what was our main motive here? Main motive was to have C and D in terms of A and B. Yes, C and D in terms of A and B. So here the sine theta has a, means they are in A and B, and here sine theta is in terms of C and D. So I can, means sine theta has value this also, sine theta has a value this also, sine theta has a value this also, sine theta has a value this also. So I can compare them easily. So I'm comparing A with this C and B with this D. So comparing the A with the C, so 4 upon square root of 5 times A is equals to square root of 2 upon square root of 2 times C. So 2 upon square root of 2 times C. So from here I get the value of C, that is C in terms of A I need. So that is equals to square root of 5 times A upon 2 root 2. This is the value of C in terms of A. As I told you, A will be there and some kind of, not integer, a real number. There was a mistake, some kind of real number. And similarly over here, if I compare B with the value D, they can be compared because the LHS is equal sine theta. So comparing that B and D, so 4 upon square root of 2 times B is equals to 4 upon square root of 5 times D. So 4 upon square root of 5 times D. So 4 and 4 got cancelled out. We obtain that D is equals to square root of 5, as it is in the denominator. It will be square root of 2 into B upon square root of 5. So this is the value of D in terms of B, the real part multiplied with B. So this C and D we can put the value over there. So we just obtained the value of C, that is square root of 5. Yes, square root of 5 upon 2 square root of 2 into A. The value of D we obtained is square root of 2 upon square root of 5 times B, and in the denominator A and B, as it is this one. Let me again check it if they are correct. Yes, D is square root of 2 upon square root of 5, square root of 5 upon 2 root 2. Yes. Now A and B cancel, A and B got, means AB, AA, BB got cancel out. Square root of 5, square root of 5, square root of 2, square root of 2. So we obtain that A upon B is equals to 1 upon 2. This 2 is left over there. So from here we have the ratio that 2 times A is equals to B. As I told you, 1 will come in the terms of other. So we get that the B is 2 times A. So we can put that over here. That, as I told you, means some kind of, we were looking here, the K was a real number. Wherever I told the integer, it's a mistake. K is a real number. So we obtain that yes, B is equals to 2 times A. So this B can be replaced with that value. So I'm just removing this thing from here and writing the new equation. So first equation, x plus A is equals to 32. Now instead of B, I can write 2 times A. Yes, 2 times A is there. So now x plus 2 times A is equals to 36. I can multiply this equation by 2. So 2 over there, 2 over here, 2 into 32, that's 64. And now I can subtract this both equations. So 2a got cancelled out. 2x minus x is x. 64 minus 36 is 28. And x is equals to 28 unit square. Unit square. And that's our answer, that x is equals to 28 unit square. So this was my method to solve this particular equation. What I did, it's a very clear idea I told you. First we were looking for A in terms of B, and after that some kind of sign rule to have C and D in terms of A and B. And all that was very clear and straightforward steps. So x is equals to 28 unit square is our answer. So this was my method to solve this particular equation. If Sir Michael Penn you are watching, do comment. If you are watching or anybody is watching, do comment below how was this method. Your method was very, means you just did it in 5 minutes using the coordinate geometry, but as you asked, is there any other method? I have to make this video. So x is equals to 28 is the answer. If you have any other method other than this, do comment below, or else you can DM me on my Instagram, or else if you have a maths YouTube channel, you can do make a video. But the method should be different from mine and from Sir Michael Penn's. Yes. So if there are more way to solve a similar question and the viewers can see it, it's best knowledge.